day everyone. This is Darshan Seshatri, KS, in here to make a presentation in the topic of facial recognition. We will be seeing what is face recognition, the key difference between these both, and the steps in the facial recognition, along with an implementation of facial recognition in Python using the package face recognition, which was written over DL. Without taking much time, let's get into the topic. Introduction to facial recognition. Facial recognition is a technology that identifies or verifies individuals by analyzing patterns based on their facial features. It has widespread applications in security, access control, surveillance, personal devices, and much more. The technology has evolved significantly due to advancements in computer vision, machine learning, and deep learning algorithms. Now, what is face detection? Face detection is the process of locating human faces in images or videos. It is a crucial step in facial recognition systems as it identifies regions of interest where facial features are present. Various algorithms and techniques are used for face detection, ranging from traditional methods to modern deep learning approaches. Now, hard cascade and hard cascade frontal face classifiers. We have to know that face detections, as said, can be performed using various algorithms. Few notable algorithms to perform face detection are hard cascade based detection, DLIP based detection, MTCNN based detection, and the OpenCV's native DNN based detection. Out of these, hard cascade based detection and DLIP based detection has gained various popularity over the years. Hard cascade and hard cascade frontal face. Hard cascade is a machine learning based object detection algorithm used for face detection as well. Hard cascades have been used for object detection on low edge devices, and it was one of the most popular object detection algorithms in OpenCV. Hard cascade frontal face is a part of hard cascade project, which is a pre-trained model specifically designed for detecting frontal faces in images or videos. Now, let's discuss about facial recognition and the difference between face detection and face recognition. Facial recognition is a technology that uses machine learning algorithms to identify and verify people's identities based on their facial features. We have already discussed the same in the introduction slide. It has become increasingly popular in recent years. As you know, for security and surveillance purposes based on face recognition, we use this, and we make unlocking smartphones and monitoring public accesses using facial recognitions as well. Face detection and face recognition are two related but distinct technologies. Face detection is the process of detecting the presence of face in an image or video, may it be one person or many persons' faces, but it is used only to detect and locate the faces of the person in an image or video. But in contrast, face recognition is the process of identifying a specific person by comparing their facial features to a database of known faces. That is, it has face detection as a part of it, but rather than only detecting faces, it also finds who the particular person is. So, this is used to verify someone's identity based on their face. Facial recognition technology has become a controversial topic due to concerns about privacy and potential misuse. Some people worry that it could be used to track people without their knowledge or consent, or to unfairly target certain groups of people as well. So, this was a downside of facial recognition. However, it has been evolving since a longer period. Now, we will see its history. So, the facial recognition part actually started from 1964 itself. In the year of 1964, the American researchers Bledsoe and his team studied facial recognition computer programming. They imagined a semi-automatic method where operators are asked to enter 20 computer measures such as the size of mouth or the eyes, etc. In 1977, the system was further improved by adding 21 additional markers like lip width, hair color, etc. In 1988, artificial intelligence was introduced to develop previously used theoretical tools, which showed many weaknesses. Mathematics, especially linear algebra, was used to interpret images differently and find a way to simplify and manipulate them independent of human markers. In the year of 1991, Alex Petland and Matthew Turk of the MIT presented the first successful example of facial recognition technology, agent faces, which used the statistical principal component analysis method. In 1998, to encounter industry and the academy to move forward on this topic, the Defense Advanced Research Projects Agency, that is shortly known as DARPA, developed the Face Recognition Technology Program, which was named FERRET, which provided the world with a sizable, challenging database composed of 2,400 images for 850 persons. In 2005, the Face Recognition Grand Challenge (FRGC) competition was launched to encourage and develop face recognition technology designed to support existential facial recognition initiatives. In the year of 2011, everything has been accelerated due to an acceleration in the field of deep learning and machine learning method based on artificial neural networks. The computer selects the points to be compared. It learns better when it has been supplied with more images. In 2014, Facebook got to know how to detect faces by its internal learning algorithm developed by the company Facebook itself, named Deepface. The social network claims that its method approaches the performance of human eye near accuracy, that is 97%. What a mind-blogging accuracy. Now we will see how hard cascade and hard cascade frontal face works. What is hard cascade and how it works? Hard cascade is a feature-based object detection algorithm to detect objects from images. A cascade function is trained on lots of positive and negative images for detection. The algorithm does not require extensive computation and can run in real time. We can train our own cascade function for custom objects like animals, cars, vehicles, etc. as well. Hard cascade can't be used for face recognition since it only identifies the matching shape and size. Hard cascade uses the cascade function and cascading window. It tries to calculate features for every window and classify positive and negative. If the windows could be a part of an object, then it is positive, else it's negative. Hard cascade can be understood as a binary classifier. It assigns positive to those cascade windows that has been part of our object and negative to those that has not been the part of our object. Now, we can come to the limitation of hard cascade. However, hard cascade is very still popular for objects like faces, cars, etc., where the objects are easily distinguishable. Hard cascade can't work for deep object detection like types of grain, etc. So, as discussed, there are a lot of pre-trained hard cascades for eyes, for ears, for face, for lips, for bodies, for object detection, etc. We can also train our own hard cascades as well. So, implementation of face recognition systems. Main steps in face recognition systems during implementation are: first, we have to perform approximate face detection and normalization. Second, we have to extract features and accurate face normalization. And in third, we have the classification, that is the verification or identification on a database of known faces. So here we have the applications of facial recognition. The few applications in health sector include diagnosing genetic disorders. So these genetic disorders are nothing but especially the disorders that can be even found visually in face. So the Delaware's numerous children's hospital deployed this technology. As clinicians struggle to diagnose a patient experiencing unusual symptoms, they turn to Face2 Gene algorithm, a face recognition powered mobile app that Dr. Karen Grip, one of the hospital's employees, helped develop. The application scans patients' photo, mapping their face with 130 landmarks, and use this with a machine learning to match detect facial characteristics those to rare genetic conditions. As a result, the application generates a list of potential diagnoses with each with a probability score. With Face2 gene, the doctors diagnose that patient with rare cases of Wiedemann-Steiner syndrome. Similarly, it can also be used for mental therapy as well, where we can find the emotions of persons as well. In the applications of education sector, it can be used for campus security, like to know who is roaming where and where are certain persons. To track them, we can use in campus security, as well as we can use it for attendance monitoring as well, where we can have a face recognition based attendance system to note, maintain, and manage the attendance system as well. So that's it. Now let's get into the part of implementation. Before moving into the implementation, you have to have some prerequisites in order to implement the project. Let's discuss these prerequisites one by one. First, the thing is you have to have a Python which is greater than the version of 3.7 and less than 3.10 in order to avoid stability issues and errors. You can check if you have Python or not with that version or not by opening your project directory and opening a command prompt in it. Then type python space hyphen hyphen version to know the version of Python that you have. If you don't have a Python and get any error if you put this command like python hyphen hyphen version is not an internal or external command, then go to python.org. This is an official website of Python to download. Now then go to download and download Pythons as per your desktop requirements and the versions that we have mentioned before. Next, I have Python installed. So now you have to install CMake. For that, you have to first download the setup of CMake from their website and install it. For downloading CMake, you go cmake.org. This is the official website for CMake. To download the CMake, head to the downloads directory. So here you can find n versions. If you are Windows user, then download this. If you are a Linux user, then you have a table source file in here and install it accordingly. And for Mac users also, here we have a setup file. I am a Windows user, so I have downloaded the Windows setup. After the download has been done, open the setup. So it checks whether it has the what it has to do and what it has to be done. Next, it will show a wizard like this and tell you to navigate. Just click next, accept the license terms and agreements. Add CMake to system path for all users. This way, CMake will be installed as well as the path will be added to all the users that are being used by your system. So just click next, install. It will install CMake in your system. Meanwhile, this installation is happening. Let's see about the next requirement, that is Visual Studio build tools for C++. For this, we have to download the Visual Studio first. Visual Studio download. So since this is minus Windows version, it automatically deleted and we have free download for Windows. So go and choose the community version only. Here you can see community, professional and enterprise. Just choose the community version only. That is only the free option. Download this setup too. Now after the setup has been downloaded, just click to open it. Click yes to proceed. Then set up this installer. Meanwhile, check the CMake too. It's being installed. Now the setups for the Visual Studio installer is being downloaded and it is also being installed. Now we have to set up the Visual Studio C++. I have already had this, so while updating, I faced an internet issue. So I'm going to retry. So it will show like this. If you are a new user or if you have downloaded it newly, you will find a pop-up like this showing what are all the things that you can download and install. Now here you can head to the site where you find desktop and mobile and click the desktop development with C++. This is the build tools for C++. Now click this, enable this. So this build tools requires 18.51 GB. Just click modify. But it will download nearly 4 to 6 GBs of data. Retry. Continue. So if you have any previous things being running, it will uninstall them and it will install those new packages during update. If you are new, it will install the newer version as shown. Similarly, you see that the CMake setup has been finished. Click finish to exit setup. Let's Now see about the next requirement for the project to run and being implemented. You have to create an environment. So if you are done with Python downloading and installing, we can proceed to this step while Visual Studio C++ tools is being downloaded and installed. So now head to your project directory. This is my project directory where I have already have the scripts of face detection and face recognition, but I also tried it with an environment. Now I will delete it and I will show how to set up an environment. Open command prompt in your project directory and type python space hyphen m space venv space env. In the script, you are instructing Python to create a virtual environment. That is, this venv is nothing but virtual environment with the name of env in this project directory. So when you hit enter, an environment with name env will be created in your project folder. So since this takes 6 GB of data, it requires some time. I am pausing the video for now. And in meanwhile, you can see that the environment has been created. You won't get any messages. But if you open the project directory, you can see a folder named env. So that was the name that we kept for our environment. Within this environment only, we are going to install two packages, namely OpenCV and face recognition, which I have put in here after activating the environment. So currently I'm pausing this presentation so that we can restart once when the download and installation of Visual Studio Code build tools for C++ is being downloaded and installed. So once all your installations for Visual Studio C++ build tools are complete, you can see it like this. All installations are up to date. To cross verify, you can click modify. So it's telling getting things ready. Once it enters the dialog block, you can see that desktop development C++ is ticked and the total space required is 0 bytes. So this confirms that our installation has been successful. So we can close and proceed to set up our application. Now we have to go and activate the environment that we have created already. So environment slash scripts slash activate. So this helps us activating the environment. Now we have to install the libraries that are required for our implementation. The two libraries which we require for our implementation is OpenCV Python. Okay. Install OpenCV-Python and face recognition. Hit enter, then installation will be started. Pip is nothing but it's a package management tool for Python. So since I have already worked with this, it's collecting the cached version of the packages. If you download it newly, it will get downloaded from first and only then it will start installing. For me, I have those cached versions, so it's collecting those cached versions and installing for me. So with this, our installation of necessary dependencies also comes to an end. Now we have to just implement the project. But before that, we have to do something in hand. That is, within our project directory, you can find here a folder named persons data, right? So I request you also to create a directory with the same name in your project directory and keep a photo of yourself or a whomever with which you have to perform the facial recognition. That is, this this folder will act as a database of all the person's face images with the file name and their names. So with this particular database only, we are going to perform face recognition. For my case, I have only one images. That is only my photo for this facial recognition, and I have named it with my name. Now we have to open a code editor for seeing our program and implementing the same. So I have Visual Studio Code. So I am opening the same. You can use editor of your preference, but I prefer Visual Studio Code. So first, we shall look onto face detection. We have already discussed that I am going to use hard cascade frontal face for just the face detection part. So first, we have to import the necessary packages to perform face detection. The package that we are going to use for face detection is OpenCV. The shorthand notation for importing OpenCV is import OpenCV2. This is the only way that we can import OpenCV. Next, to perform face detection, first we have to load the hard cascade frontal face classifier to a variable. So this is how we create a variable and assign the loaded hard cascade frontal face. So this CV2 dot cascade classifier is which we add the hard cascade frontal face path. You can either download this from internet and provide that location, or else we have installed CV2 right now. In that pro- package itself, we will have these hard cascade data too, so we can import from them too. What I have done is I have imported the hard cascade frontal face from the package directory itself within CV2.cascade classifier. So with this, our pre-trained hard cascade frontal face model has been loaded to a variable. Now cap equal to CV2 video capture. So what we are doing is we are creating a video capture object using CV2.video capture, where this 0 tells that we are using our primary camera, that is the primary camera of our machine, to perform the video capturing, in which we will be performing that face detection. So it checks whether the webcam is available or supported or not. So if there is some issue with the webcam, you will get this error that unable to open webcam, and this entire script will come to an end. If your webcam is properly working, then it will come to this while loop. So this while loop has the logic that we have to implement to perform face detection. So what this loop does is it every video can be considered as an image sequence, that is sequence of frames. Each frame can be considered as an image. So in each image we will be performing this face detection. So in the entire context, for entire video will be processed as frames, and each frame we will perform detection and we will show it in the screen. So when multiple frames has been performing and undergo face detection, and multiple frames has been detected with frames, and if we show it in the same speed, that is in the same frame rate, we will get back it as in the same speed of the video that we recorded also. So this is how it will be. Now we are initializing the capture object by reading it. What this does is it captures the frame for each loop iteration. So if we can't find the frame, it will be throwing an error that unable to capture frame, and this will come to an end. It will break. Else what it will do is it will convert the captured frame into grayscale frame. Why we have to convert the captured frame into grayscale frame is because when we process the colored image, more time will be taken to process the same. Whereas in the grayscale frame, we have only one channel, not three channels as in the case of RGB frame. So performing face detection in single channel using cascade classifier is easier as well as less time consuming. So we pass the gray frame for the uh, face detection. Next, what we do is we capture the faces using this line, where we already have loaded our cascade classifier in the variable called face cascade. We use that loaded variable here, and since it is an object, we call the function detect multi-scale with parameters of gray frame, that is the frame in which we are going to perform the face detection, and the scale factor is nothing but how good we have to perform, and this min neighbors is nothing but how much faces at max we have to identify if it is present in video footage or photo, whatever it is, and min size is nothing but the height and width of the box that is being drawn. That is the minimum size of the box that is being drawn. So now here you can see that for x, y, w, h in faces, this is nothing but the return type of this faces object will be as a numpy array. So in that numpy array, for each index, we will have this particular set, sorry, this particular tuple. So what we have is x is for x coordinate, y is for y coordinate, w is for width, and h is for height. This xy marks as a point. in a coordinate plane. That is, if we take a square shape, we have top left point, bottom left point, top right point, bottom right point as its 4 points in a rectangular or square. This x comma y tells us the top left point of a box. And this width and height provides how much width and how much height should that box should have from that initial point, top left point of x comma y. So with this range, we are going to draw a rectangle. So where x comma y is the top left point, x plus w and y plus h is the bottom right point. And the color that we are using for this is green. You can see this is blue, this is green, and this is red. And this is nothing but the thickness of the line. So we pass our color frame, we pass the region or coordinates with width and height, and we use that information to draw a rectangle for our face. So next, with this frame with the rectangle being drawn, we pass this frame, that is this color frame, uh, as an input to the cv2.im show, which shows the output as a frame. So when this loop runs, each frame passes through all these, and each frame will be shown on the same canvas. So it will be like a video is being playing, but it's nothing but sequence of images changing in that particular frame rate, whatever the camera is capturing in the frame rate, whatever the process has been done, after that it will be showing. So this line nothing but it breaks the while loop. Why we have to break while loop is nothing but the way from which we can stop the video capture to come to an end. Why we have to come to an end is because we can't just allow to click and close the output of the same. So if we give a keyboard interrupt of Q, this entire looping will come to an end and face direction will stop. Then these are nothing but these are just cleanup processes. This will release the video camera from the video capture, and this will destroy all the canvas windows that has been opened during cv2.im. That's it for the explanation. So now let's go to the command prompt that has been opened in our project directory with the environment activated, which you can see here. So now I'm running this face detection program. So it takes some time. So here you can see that my face is being captured. I said you can't close it using the close arrow. So that's what you see in here. How much times, no matter how much times I click this, it won't get closed. So when I press Q, this comes to an end. So the face detection has been stopped when I press Q. So this is about face detection using a R cascade frontal face. Now let's go on to face recognition. First, we import all the packages that are required for face recognition. First, the face recognition package itself, then the OpenCVs package, then the OS package. This OS package is used for the manipulation of directories in our PC, personal computers or PCs, whatever it is. Here, we use this OS package in order to refer the data location. That is where our database for face recognition exists. That is this person's data folder. In here only we have all the images that are to be added in the directory of face identification, that is this known face encodings. And these empty lists, known face encodings and known face names, will be having the face encodings and face names of persons that are being stored in this database. So for storing those persons encodings and names, we have initialized these two empty folders. What the program does is it uses this for loop to load the data, that is the entire data from this person's data folder. What data it loads is the face encodings and face names of those persons. Where this loop tells us that open the database folder, that is for each file in that folder it takes the name, and using these each name it splits the name from first. So this name has two things: Darshan splitted by a dot. Then we have JPEG. So when we perform OS dot split text, we will be having Darshan comma JPEG. Out of that, we take the first thing, that is the name of the person Darshan, and assign it to a variable name, person name. Similarly, we use that uh, person image file, that is that name, and we will be putting that, you using that name to read the uh, path of that particular person, and use that path to read the image from that path. For reading the image, we use cv2.imread, and for the path to be provided, we use the path that we have uh, got in the previous slide. And with this read image, we perform face recognition or face encodings, which will extract the face encoding from that image. This zero is nothing but it enunciates that we are taking the first encoding in that encodings list. Sometimes, if our image or data has multiple faces, multiple face encodings will be returned as a list. To get the first encoding in that encoding list, we use this to get that particular encoding only. Then we append this face encoding in that empty list, and then we append the corresponding name to the names list. So in this way, if we perform for the entire project directory using this for loop, the entire data present in that particular data folder, that is this person's data, will be added to known face encodings and known names. Then after this, we are capturing or initializing our webcam using the CV2 type video capture, and this zero, as already discussed, is referring to our primary camera, that is the primary webcam that we have. Then this while loop is to iterate through each and every frame during the video capture through our webcam. Then in each frame, the frame is being read. So if no frame is detected, this error, that is unable to capture the frame, will be thrown. If the frame is being read, then we will find first the face location. In the previous program, face detection, we used hard cascade frontal face pre-trained frontal face model for detecting the face present in the image or that frame of that particular video. Instead of hard cascade frontal face, face recognition itself provides a way to get the locations of the face. So what we are doing is we are getting the face location from that particular frame, and we are using this location on that particular frame to get the encodings of the face. As said here, a particular image can have from one to many encodings depending upon the number of persons that are present in that particular frame. What this particular thing can do is, using this particular face location mapping to the particular face location, what is the face encoding it can get. So with this, what we can do is we can get face encoding for each face locations in a video capture. Then we use this face encoding on that locations, that is being a tuple of top left, top right, bottom left, and we use this particular line to on this particular loop to compare through all the faces that we have already in the database. First, we will be having the name initialized as unknown. Then we will go through each and every data with these two lists. So while going through each and every data through those lists, we will try to compare the faces. If any one particular thing matches, we will use that matched index to retrieve the known face name, and using that known face name, we will draw a bounding box where we already have the frame, we already have the left top and right bottom coordinates, we know what color to keep, and we know what thickness. So using this data, we draw a bounding box using that face location, and for face encoding, we have this particular matching part where if we get matches as true, and we use that particular location. For example, if face recognition has this particular list has multiple faces, this is our encoding. Wherever the encoding has not been matched, there in those places we will have false in this list. Wherever the encoding is only matched, that is the encoding that we want. If it is present in this particular list and both of the things get matched, then that particular index will be true. If the two in that particular key element is present in this list, We are getting the uh, index of that list and using that index in our known face names and retrieving the known face name, which we use cv2.putText to write that name in that bounding box, where we mention in which frame we have to write it and the name and where we have to write it. This is the position of the name where we have to write, and this is nothing but which font we have to use. This is the size of the font that we want to write. This is the color of the font, green, and this one represents the thickness. So this is the thing that will happen in each and every frame during this while loop. So after all this being done, in each iteration, this IM flow will work. So for successive iterations in the frame rate, for in the same canvas, every other frame shall be displayed or overlaid. So we will get an video effect. So with this, the detected frame will have the bounding box at the face location as well as the name being written using this cv2.putText. Next, we have the same logic, that is the breaking of that particular video capture using the letter Q. So whenever we press Q, the video capture will be stopped. So once that's happened, this entire while loop will break and we will perform cleaning up processes. That is, we will release the webcam from CV2 and we will destroy all the canvas windows that we used to perform CV2.im show. That is, we used to show the frames. So this is the entire explanation of the code that we have in here for the face recognition. Now let's run this particular code. I am going to the same command prompt where we previously run the face detection file. Now we are going to run face recognition. So face recognition. By using this, we can run the face rec.py file. Sorry, it's a typo error. So what is happening is background is it will first start. It will go on through the database and it will get the known face encodings and names of them and store it in its list. And then slowly CV2 will initialize, video capture will be starting, and once the video capture has got the web camera, using that web camera it will go on through a while loop and it will start performing face recognition. So you can see that it has been started performing face recognition. So it is a little bit laggy, but we are getting the face recognition being performed. So you can see my face. I am also keeping like this. So now you can see my face is being captured and the face has been exactly drawn the bounding box, as well as my name has been put in the bottom of that bounding box. Now if I close, similarly the box won't be closed and it will appear again. When I press Q, it comes to an end. So this is how we perform facial recognition. So thanks for coming out and reaching to this presentation. Thank you.